Hi everybody, today we are going to look at the area of plane figures. And you see that word there, plane, meaning these are two-dimensional figures as compared to a 3D object, or what we would call a solid. So for this section, we have formulas for the area of many different things here: rectangle, square, circle, trapezoid, triangle, and parallelogram. And what we want to do here is I really want you to zero in and start focusing on your SOL formula sheet, because this is what you will have when you take the SOL. If you see here, these first 1, 2, 3, 4, 5, 6, these are what you're going to need for the plane figures. So it gives us the area as well as the perimeter. Here we have the circle, circumference, an area for that. And I want you to, when you're doing your work, to utilize this formula sheet, because then you'll be very familiar with it once you do the SOL. So for this section here, the basics that you're going to do are basically just look at the shape, and then you're going to look at the formula sheet and plug the values in that you need to calculate what they're asking. So all of these here are finding the area. And so if we just take one for example here, we have a parallelogram on number 3, and we can see the formula, and the formula is right here on my sheet. So it's just going to be the area is the base times the height. So I'm going to write area is equal to base times height, and then I'm going to plug in my values. So I have A is equal to 12.9 times 7.1. Calculate that, and it ends up being 91.59 inches squared. Okay, so what I want you to do is I'd like for you to do all of the problems on this page, and then on the back side go ahead and do 11 and 12 as well. And then for the word problems here, just go ahead and do number 13, and how about number 18. So I'd like for you to pause the video at this point and go ahead and do all these problems, and then I'll put a key up so that you can check your work. All right, so here are answers for 1 through 10. Just take a look through all of those. You can see if you got them right. If you didn't get them right, pause the video so that you can look and see where you went wrong with your calculation. Okay, for 11 and 12, you use Pythagorean theorem to determine your height here, and you also do the same thing with number 12. So that one was a little bit more difficult, but once you find what that height is, because from this point here over, that's going to be 6 because of 19 minus 7. You can find the height as 8 and then plug it in. Okay, and then this is number 13. If you wanted to do the other ones, you can see the answers as well. And then here we're just solving for the height. And then for number 18, we are solving for the perimeter. Okay, so that's it as far as the notes go. I'll put this one down here too, just for any of you who wanted to work that out. Those are our notes for this first section, areas of area formulas. And I'm not going to assign you any homework for that section. If you just do all the problems there in the notes, I think that would be great. Next, we're going to look at the area of a sector of a circle. So a sector is a section of a circle bounded by a central angle and its intercepted arc. You can think of it as a sector as like a slice of pizza. So here we make sure we're looking at the central angle. That means that this angle here is sitting right at the center of the circle, and the shaded part would represent the area of that. So here we have the area of a sector of a circle. We have a formula for this, and this is very similar to when we calculated the length, the arc length of just a piece of a circle. All right, so our formula is going to be A is equal to x, so that's our degrees, times pi r squared, which is the area of a circle, and we're going to divide by 360. So as I mentioned, this relates to our arc length calculation because here we're taking this degree and we're saying this x divided by 360 gives me this portion of the circle. And then instead of multiplying it by the circumference, which is what we do with arc length, now we're going to multiply it by the area because we're looking at what piece of this pizza, if we think of it that way, is what's the area of this piece of pizza. So we've created essentially a ratio of this, whatever this degree is, divided by 360, so that's the portion of it, and we multiply it by area. All right, so let's go ahead and look at the first one here. So here we have 51 degrees. That's going to be our degree measurement there. So our area is going to be equal to, we're going to say x here is 51, and we are going to divide that by 360. That gives us our ratio. And then here we want to multiply it by pi r squared. And that's our area of the whole circle. So the BC here, they tell us, is 16, and that is our radius. So we're just going to put 16 into our formula there and square that. Okay, so when we calculate this, we should get, put it in your calculator, you should get 113.94 feet squared. Go ahead and do number 3. Pause the video and then we'll check it. You should have gotten 6.6 millimeters squared. Let's look at number 5 now. Here they want this shaded region, and they tell us that this is 42 degrees here. So we're going to take 360 and subtract the 42 so that we find out that this shaded region here would have a 318 degree measurement. And then just put it into your formula. So A is equal to 318 pi times my radius, which is 9 squared, and we're going to divide it by 360. When you put that in your calculator, you should get 224.78 inches squared. You turn your paper over. I'd like for you to do number 8. Pause the video and then we'll check it. Okay, for number 8, the shaded area is going to be 270 degrees because this is 90 degrees. And then we plug it into our formula and we should get 2050.48 miles squared. For number 11, here we want to find the total area of the shaded region, and we're going to be utilizing some vertical angles. So if this piece of the pie is 46 degrees, then this one also would be 46 degrees. So we want to add those two together and we get 92. And so now we're going to put it in our formula, and we have our degree measurement for both of these would be 92 times pi. Our radius, HG, is 7, and we'll square that. Divide by 360, and then in your calculator, you would calculate it and get 39.34 centimeters squared. All right, why don't you go ahead and do number 12. Pause the video and we'll check it. Okay, here's the answer to number 12. We knew this was 113, so this vertical angle here needs to be 113. We add those two together to get 226. Here they said XY was 30, so we just had to be careful. They gave us the diameter, so we know that half of that is the radius, which is going to be 15. So you want to put 15 in, and then your answer should have been 443.75 feet squared. Okay, so that was all I was going to have you do for this note section. You don't have to finish all the problems. The only thing I would say is that if you're struggling with this at all or feeling like you don't understand it, then I would choose some problems on your own, take responsibility for your own education here, and work any problems that you would like Here's the answer for the rest of them, 11 through 16. And then also this was 7 through 10. And then on the front side, here are all of the answers as well. That's 1 through 6. And then 7 through 10. But I feel like if you understand the problems that we did together and the problems that I asked you to do on your own, you should be good to go. All right, so that's it. That covered 2 sections of notes, the area of a plane figure and then the area of a sector of a circle.